Good morning students, welcome to video lecturing class on dynamics of machines. So in the last class we have seen about the balancing of rotating masses. The theory part we have discussed and we have solved one simple problem. So today we will continue with the one more problem. So the question statement is: a shaft carries 4 masses M1, M2, M3 and M4 attached to it. They all revolve in the same plane. The magnitude of the masses are 6, 5, 9 and 7.5 kg respectively. The center of gravity of the masses are located at a radial distance of 100, 125, 150 and 75 mm from the axis of shaft. The angular positions of the masses are 60 degree, 135 degree, 270 degree from M1. Determine the position and magnitude of the mass M5 at a radius of 250 mm to balance the system. So here he has given that for a shaft 4 masses are attached and their respective mass and radius of rotation he has given, and he has given their angular position also with respect to M1, and he asked us to determine the mass of the balancing body, that is M5, which is rotating at 250 mm radius. So the first step is you need to construct this tabular column. First column mass, radius and force. So you know 4 masses M1, M2, M3, M4. Radius he has given and force is nothing but M into R. That product you have to write. After that you need to construct this space diagram. So here he has given the angular positions with respect to M1. That means M1 is along horizontal plane. So for M1 angle will be 0. So first M1, for M2 he has given 60 degree as the angle. For M3 he has given 135 degree and for M4 he has given 270 degree. So now our work is to determine the mass of this balancing body, that is M5, and this theta phi. So after the construction of this space diagram, you need to construct the force polygon. So to construct the force polygon, you have to use this tabular column. Okay, that is this last column. With the help of this last column, you need to construct the force polygon. So now, to start with, you need to select the appropriate scaling factor. So here I have taken 10:1. That means 10 centimeter equal to 1 magnitude. That is 1 Newton force I have taken. Okay. So the first one is for M1 it is 0.6. So starting from here, it is 0.6. O to A, length of this line will be 0.6 and angle will be 0 because for M1 the angle is 0. For M2 it is 0.625. The angle is 60 degrees. So from A to B you need to construct a line of length 0.625 and angle should be 60 degrees. Likewise, next from B to C, the magnitude of the line is 1.35 and angle is 135 degrees. So that for last, the magnitude is 0.5625 and angle is 270 degrees, which is given. That is from C to D. Then to calculate or to determine the balancing mass, you need to complete this force polygon. So to complete that one, join this end point to the starting point. That is from D to O, you need to draw a straight line. Okay. So the angle with respect to M1, that is in counterclockwise direction, will be theta phi. So once you complete this force polygon, measure the distance between D to O, or measure the length of this OD line. So from force polygon, O to D into scale is equal to 0.25 M5 because I have taken these length of these lines as the magnitude with respect to their masses. So since it is for the M5, so he has given its radius of rotation as 250 mm. So O to D into scale equal to 0.25 into M5. So substituting OD value from the force polygon, substituting the scaling factor, you will get M5 as 3.76 kg. And if you measure the angle in counterclockwise direction, it will be 273 degree with respect to M1 in counterclockwise direction. So this is the complete solution. So here the balancing mass is 3.76 kg and its angular position is at 273 degree. Now moving further, the next problem. The statement is 5 masses M1, M2, M3, M4 and M5 revolve in a same plane. So these problems are for the rotating masses which are in the same plane. Magnitude of M1, M2 and M3 are 5, 2.5 and 4 kg respectively. Angular positions of M2, M3, M4 and M5 are 60 degree, 135 degree, 210 degree, 270 degree from M1. Determine the masses M4 and M5. So here he has given the angular position for all the masses and he has given the mass M1, M2 and M3 only. He has not given the value of M4 and M5 which you need to find out. So, and he has not given any information about the radius of rotation. So in such cases, you need to assume that all the masses are rotating in the same radius of rotation. Therefore, assume the masses are revolving at equal radii. R1, R2, R3, R4, R5 are equal to R. So now then we need to construct the tabular column. First one is mass, radius and force. So list the masses here. 5, 2.5, 4, M4 and M5 are unknown. And these are the radius of rotation which is unknown. We can keep it as R only. Then take the product. So R is common everywhere. So I have not written here. So 5, 2.5, 4 and M4 and M5 are the force column here. After that you need to construct the space diagram. So M1 is along the horizontal plane and for M2 he has given angle as 60 degree. For M3 he has given 135. For M4 with respect to M1 as 210 degree and for M5 he has given the angle as 270 degree. After this you need to construct the force polygon. To construct the force polygon you have to use these force terms. Take the proper scaling factor. So here I have taken 1:1. It is not mandatory, always you have to take one same scaling factor. So O to A need to draw a line of length 5 and angle will be 0. That is for M1. For M2 it is force term is 2.5. So from A to B length is 2.5 and angle is 60 degree which is given. Then from B to C the length is 4 and angle is 135 degree. After that we don't know the force magnitude for with respect to M4 and with respect to M5. But we know the angular positions for M4 and M5. So first what we'll do, by taking this C as the reference point, keep your protractor along this line like this. Okay. Draw a line of random length which makes an angle 210 degree with respect to horizontal plane. Okay, so length of this line will be random and the angle will be 210 degree. Then for M5 he has given angle as 270 degree, but we don't know the location or end point for that M5. D still it is unknown. Okay, so for that we will draw a line from this origin point. Okay. And along this horizontal line or horizontal plane, if you take the angle, it will be 90 degree. Because for M5, he has given angle with respect to M1 as a 270 degree. So 360 minus 270 will be 90 degree. So from O, draw a perpendicular line or draw a line which makes an angle a 90 degree with horizontal plane till it intersect with this random line. Okay. So wherever these two lines will intersect, that point is going to be D, and the length of this C to D will be M4 and the length of this O to D will be M5. So here what we have done, so from C we have drawn a line of random length to 10 degree. This length will be random first. Then from this O, draw a 90 degree line till it intersect with this random line. Why it is 90? Because the angle for M5 he has given it as a 270 degree with respect to M1. So 360 minus 270. If it is 260, that time it will be 360 minus 270. That means that time you need to draw 100 degree line. Okay, so here it is 270. So 360 minus 270 is 90 degree. So draw a perpendicular line. You will get D. So now from from force polygon CD, C to D into scale is equal to M4. So which will give you the mass of the fourth body as 4 kg. Similarly, this D to O or O to D is M5. OD into scale equal to M5. So M5 will be 3 kg. Okay. So now these are the problems in which the masses are rotating in the same plane. Okay. So whenever that is the reason why while reading the statement you should check whether the masses are revolving in a same plane or in a different plane. Okay. If they are revolving in a same plane, that time only you need to construct this force polygon, tabular column, then space diagram, then with all of that force polygon, really you can determine the unknown values. Now moving further, here one more condition will come, that is balancing of several masses in different plane. So previous was balancing of several masses in the same plane, but here it is balancing of several masses in different plane. So let us consider a shaft which is carrying 4 disturbing masses M1, M2, M3 and M4, and they are revolving in the planes A, B, C and D respectively. So here they are revolving in the different planes. So in order to balance this system, assume that 2 balancing masses are introduced. One balancing mass is BL in plane L and another is BM in plane M. Okay. The angular position of the masses M2, M3 and M4 are alpha, beta, gamma with respect to M1. So for perfect balancing, the sum of the couple about any plane must be equal to 0. The summation of MRL into cos theta equal to 0 and summation of MRL sin theta equal to 0. Similarly, sum of the centrifugal force must be equal to 0. Summation of MR cos theta equal to 0 and summation of MR sin theta equal to 0. So in such cases, the first step is you need to construct this line diagram, then this space diagram. After that, you need to construct the tabular column. In previous problems, we used to have only 3 columns, but here we will have 6 columns. Okay. So first one is plane, then mass, radius, force. So these 3, column number 2, 3, 4 are same from the previous problems. So the addition to that column is, table is plane, the first column, then mass, radius, force. Then you have to take distance from reference plane. So while taking the reference plane, you need to take a plane in which you don't know the value. For example, here you have 2 unknown masses, that is BL and BM, which are acting on L and M respectively. So either you can take L as the reference plane or you can take M as the reference plane, which will be easy to solve the problem. Okay, so distance from reference plane, then couple, that is going to be equal to force into distance from reference plane. So in the first column, you need to write all the planes. The planes are A, L, B, C, M, D. Masses are M1, BL, M2, M3, BM, M4. Radius R1, BL, R2, R3, BM and R4. Force is nothing but M into R. Distance from reference plane. So here first I have written minus L1, because if you take this L as a reference plane, it is plane A is towards left side. So you need to take the left side as negative and right side as the positive. Okay. So distance from the reference plane for A is L1 here. This is L1, and distance from, so for second row it is L, so that will be 0. For third it is L2, L3 and D and L4. So couple will be force into this distance from the reference plane. Just you need to multiply and you need to write here. After this, the very first step is you need to observe two columns here in this tabular column. The first one is force column and the second one is couple column. So in these two columns, you need to decide which diagram you have to draw first. Whether you have to draw couple polygon or whether you have to draw force polygon. So the only thing is you need to verify that in those two columns, you need to select a column in which you are having the minimum number of unknowns. So here if I take the force column, M1, R1 he will be giving in the data, BL this is unknown and this is unknown. Just all remaining four things will be known. But here this is already 0. So here only one unknown is there. So that means first you need to draw the couple polygon. So to draw the couple polygon, you have to use the data from this column, that is last column, couple column. So first one is minus M1 R1 into L1. So 0 to A, sorry here, O to A will be M1 R1 L1. So here I am drawing this line in this direction because that is with a negative sign, first term. Okay, if it is positive, that time this would have been your O and this would have been your A. So O to A, M1 R1 L1. Next you know the angle with respect to M1. Second one is 0, skip that. Then B for mass B, that is for second mass, the angle is alpha. We know the magnitude. Then it is beta, then it is gamma. And from here you need to join this D to starting point to get the unknown values. So in this case, in this column only unknown is BM into D. That is the balancing mass on the plane M. So length of this line will be DOD into scale equal to this one. So from this you will get the balancing mass in the plane M. Once you get this value, substitute that BM in this column. So here only unknown is going to be this mass, which is thing on plane L. So you need to draw the force polygon. So here the first one is M1 into R1. So O to A. So here it is with positive sign. So I am drawing in this direction. But while drawing couple polygon, it is with negative sign. I have drawn like this in this direction. Okay. So O to A to B, B to C, C to D. Then for the next, you know the angle from couple polygon, theta M. Use that and you know the magnitude of that line, BM into L, D. So after that, you join this end point to the starting point to get the value of BL. That is from force polygon, CO into scale equal to BL into BL, from which you will get the value of balancing mass in plane L. So we'll understand more easily when we start solving the problem here. Moving further, we'll start with the problem. A rotating shaft carries 4 masses, 1, 2, 3 and 4, which are radially attached to it. The mass centers are 30 mm, 38 mm, 40 mm and 35 mm respectively from the axis of rotation. The masses M1 and 1, 3 and 4 are 7.5, 5 and 4 kg respectively. The axial distance between the planes 1 and 2 is 400 mm, 2 and 3 is 500 mm. The masses 1 and 3 are at right angles to each other. Find for complete balance, that is first one is angle between 1, 2 and 4, axial distance between 3 and 4 and the magnitude of mass M2. So here he has given 4 masses. So let us first draw 4 lines. Name them as 1, 2, 3, 4. and he has given mass centers, means these are all the radius of rotation, and he has given masses for 1, 3 and 4. M2 is unknown here, and he has given this axial distance between the planes 1 and 2 is 400 mm. 1 and 2, this distance is 400 mm, and between 2 and 3 it is 500 mm. So for this he asked us to calculate angle, axial distance and magnitude of M2. So to begin with the solution, first you need to construct this line diagram, then you need to construct this space diagram. So here this is M1, M2 is unknown here, and he has given that 1 and 3 are at right angles to each other. That means the angle between the 1 and 3 is 90 degrees. So at a 90 degree you have to show M3, and you don't know the angle for M2 and you don't know the angle for M4. So just draw with random angles. So this is the space diagram. After that you need to construct the tabular column. First one is plane 1, 2, 3, 4. Then masses 7.5, M2 is unknown, 5 and 4. Radius of rotation he has given for all 4 masses. Force you need to calculate M into R. Distance from reference plane. So here M2 is unknown, so I will take this second plane as the reference plane. So from this, for the plane 1 towards it is left side, so it is minus 0.4. Second one, for the second plane itself it will be 0 because it is at the same point. Then towards right side, third plane is at the distance of 0.5 mm, and the next one is from at a distance of x. Then couple you have to calculate, just multiply this force to distance, you will get the couple. So now you need to draw the couple polygon first, because you know the angle between 1 and 3, 2 already it is 0. If you are going to draw a force polygon first, you don't know the angle between 1 and 2 and 3 and 4 and 1 and 4. So first we will draw the couple polygon. Okay, so we know the magnitudes, we know the angle between 1 and 3. So here to draw the couple polygon, so here the first magnitude is 0.09, it is with the negative sign. So start from here, 0.09 should be the magnitude and angle will be 0. In this direction you have to draw, and the scaling is 50:1. Then the second value is here, it is 0, skip that. Then the third one is 0.1 is the magnitude. Okay, and the angle between 1 and 2 is 90 degree. 0.1 should be the distance and angle should be 90 degree. Then at the last we are having 0.14x. So to complete this couple polygon, join this B to O. So length of this line should be equal to 0.14x, from which you will get the value of x, and also you will get the value of theta 4, that is angle for the fourth mass with respect to mass M1. So from this you will get O to B into scale equal to 0.14x. So x is 0.96 meter and theta 4 is 312 with respect to counterclockwise direction. So you have to substitute these two values, sorry, this x value in this equation, in this column. Okay, so from this you will get the couple. Then you need to construct the force polygon. To construct the force polygon, you know the angle between 1 and 3, you know the angle between 1 and 4. So this angle you have got here from the couple polygon. Then start with the first origin, O to A. Length should be 0.225. Take the proper scaling factor and angle should be 0. Then the second one is unknown, M2 is unknown there, so skip that. For M3, you know the angle between 1 and 3, the angle is 90 degree. Draw that line. Then for the fourth, the angle is 312 degree, and you know the magnitude is 0.14. Draw that line. So join this end point to this starting point directly. So the length of this line should be equal to 0.038 m2. That is OC into scale equal to 0.038 m2. So from this you will get the value of m2. So finally we have found the magnitude, that is angle between 1 and 2 as theta 2 as 196 degree, and angle between 1 and 4 is 312 degree. So this 196 you need to measure it from here, from the force polygon with respect to horizontal plane, and axial distance between 3 and 4 is x minus 0.5, because this x is between reference plane to 4th plane, that is between 2 and 4. The whole distance is x. If you subtract that 0.5, that is the distance between 2 and 3, you will get 0.46 meter as the distance, and magnitude of mass m2 is 8.74 kg. So the only thing is, while constructing these couple polygon and force polygon, scaling factor is important, and to take the proper angles. So while constructing and while taking the data from this table, whenever you will get the unknown, skip that, move to the next with respect to the angles, then only, and at the end join that end point to the starting point. Length of that line always you should equate that one to the term which is containing the unknown thing, that is here this one and here this one. Okay, so today we will end the session here itself. The only thing is, in the statement you have to check whether all the masses are revolving in the same plane or they are revolving in the different plane. Based on that you have to solve the problem. If it is they are revolving in the same plane, just by drawing that force polygon you will get the answer. If it is revolving in a different plane, you need to draw the force for the full polygon first, then force polygon to get the unknown quantities. Okay. If you have any doubt, you can leave the comment in the comment box. Thank you.